We are asked now just simply to set up some limits of integration for a double integral of some function that we don't know, f of r theta, over a region R that lies inside a cardioid, 2 plus 2 cosine theta, and outside the polar equation r equals 2, which is a circle of radius 2 centered at the origin. So let's sketch our region. So our cardioid, if I think about letting theta be 0 here, I'd be at the point 4. At pi halves, I'm at 2. At pi, I'd be at 0. And so I can get these quadrantal points, and I'd trace out my cardioid, and it would look something like this. Nice, pretty cardioid. All right, and now I need to draw a circle of radius 2 centered at the origin. And so I think I see the region they're asking me to integrate over. And I definitely want to do this as a polar integral, not as a rectangular one. Now, I'm not going to be able to evaluate anything because I don't know what the function is. But this is really just practice setting up bounds, because I know this is an f of r theta, r dr d theta, right, from our previous work. So I want to think about a ray going through that region in increasing direction of r, always leaving the pole. And if I think about going through that region anywhere I possibly could, right, in increasing direction of r, I'm always hitting the circle and then the cardioid. So my bound should start at 2 and then go to 2 plus 2 cosine theta. And now I need to think about bounds for theta that would include the entire region. Pause the video and see if you can find them. So I'm hoping that you're thinking from minus pi halves to positive pi halves are the angles that would work, because those are where my circle and my cardioid hit each other. And we can actually figure that out analytically. 2 equals 2 plus 2 cosine theta. I'm looking for places where 2 cosine theta divided by 2 is equal to 0, so 0 equals cosine theta, and that happens at minus pi halves and positive pi halves. And I want to be careful. I want to make sure I'm always giving a region that includes all the points in the region as I sweep out. So I think some students here sometimes would accidentally say 3 pi halves and pi halves. Well, if I swept that out, I'd start at pi halves and go to 3 pi halves, right? I want to go from minus pi halves, a small angle, to a big angle. Those values include my entire region.